All right, hello geometry students. We're finishing up lesson 24 here today. So notice what I've got on the screen what I did before, which is talking about corresponding sides of similar triangles having equal ratios. So we created, the three different right triangles from this one diagram where the altitude is drawn from the right angle. And we're just, looking to see how we can solve for x, y, and z. So let's finish up this problem, okay? And what we have from y is a ratio right in here, that's y over 12, okay? And notice that, since that's in the longer legs hypotenuse ratio, okay, and corresponding sides are what have the equal ratios, we want to find another longer legs hypotenuse ratio that we could set that equal to solve for y, and so it makes sense to use the 12 over 13. So we would say y over 12 equals 12 over 13, okay? We cross multiply, this would give us 13y equals 144. We divide out the 13, and then we would have our answer of 144/13. Don't divide that and get a decimal because nothing in the directions tells you to round, so just leave it as exact, okay? So now to find z, let's just go to the blue. So we want to, again, find a ratio that involves z. So we've got this ratio right here, that is z over 12, that is short legs hypotenuse. So we could use this ratio of z over 5, that would be totally fine too, but we don't want to use this ratio over here of x over z or z over y because they don't have, they have another variable in it, so we wouldn't be able to solve for it. So if this is a short legged hypotenuse ratio, we're going to find another short legged hypotenuse ratio to set it equal to. So that would be that same 5 over 13, because then we can go z over 12 equals 5 over 13. We can cross multiply with 13z equals 60, divide out the 13, and then z would equal 60 over 13, and then there's our answer. Okay, so let's try a few more problems with this to get the hang of it. And in these problems, you're going to see that there's only one thing to solve for. Okay, so in this problem, it says use similar triangles to find the length of the altitude. That's it. So all you got to do is find the length of the altitude. So notice that's been labeled with the value of y, right? That would be the altitude of triangle EHF. So let's redraw these three triangles, right? So here's the EHF. And what I know in this triangle is this entire hypotenuse length is a 20, because I would add the 16 and the 4 together. All right, let's put that right angle there. Now, let's keep redrawing these so that the right angle's in the bottom left corner and so that the short leg is on the bottom. So we've got the medium right triangle, EGH, right angle is G, and then this short leg is GH right here, and then this long leg on the left would be EG. So now we know that this GH is the y, right, that's what we're trying to solve for, and EG is 16, right? So that's the long leg, okay, that we know the length of. Now in this other right triangle, the G again is the right angle, but this time G to F is the short leg, and this time G to H is the long leg, right? So G to H is what we're trying to find, which is y, and G to F is a 4, okay? So if you now look at these three right triangles that are all similar to each other, and again, corresponding sides of similar triangles of equal ratios, which triangles should we use, right? We'll look at the two that have the same pairs of sides with lengths filled in. That would be these two right triangles here. We got long leg and short leg. So we say long leg over short leg equals long leg over short leg, right? So 16 over y equals y over 4. And then we just cross multiply y times y is y squared equals 16 times 4 is 64. And what do we do to get rid of squaring? We do square rooting. And that's a nice easy answer of y equals 8. Okay, so let's try it again. But this time we have to draw our own diagram. So it says you've got right triangle ABC with ABC being a right angle. So that means we're going to make sure that B is at the vertex, right, for the right angle. And I'll just put my A and a C there. So altitude BD is drawn to AC. So an altitude means I make a right angle. And then that's going to be a D, right? So BD is drawn. And we have this length of AD, which is 8. We have this whole length of AC, which is 12. And we want to find what is BC, so we're going to put an X right down there. Okay? So now what we're going to do is, this is the same kind of diagram we've been working with all along, where we know that we've got three different right triangles in the diagram that are all similar to each other. So let's redraw them. Here's A, B, C, in which there's an X down here, and this whole length is a 12. Okay, then we have the medium-sized right triangle where the right angle's at the D, and the D of the B would be the short leg, the D of the A would be the long leg, and that's the only length I know, which is 8. There's nothing else in that triangle that I know. And I've got the smallest of the right triangles, which again still has the right angle at the D, This time DC is the short leg, so I'll put that at the bottom, and DB is the long leg, so I'll put B up here at the top. And then what can I fill in? Well, I can fill in this BC as an X, so I can put in the X right there. And I really can fill in the DC, right? Because if A to D is 8 and A to C is 12, well then that D to C length is a 4. So really, which two triangles are we gonna look at? Now it's gonna be the big one and the small one. So let me erase the one that I don't need. Okay, erase the one that I don't need. And these two triangles have short leg and hypotenuse, right? So these are similar triangles, which means corresponding sides have equal ratios. So I go short leg to hypotenuse, which is x over 12, okay, is equal to short leg to hypotenuse, which is 4 over x. And then again, I cross multiply. So x squared is equal to 48. And then I simply square root each side. And the square root of 48 is not a nice rational number, but 16 times 3 gives you 48, and the square root of 16 being 4, so this is 4 square root of 3, and I'm all done. All right, so let's do our last problem together, okay? So one more. So we've got this right triangle, and we want to find AD's length, so we'll put an X right there. And so we're going to separate these. We've got our biggest right triangle with the right angle at the C, and we've got the short leg of the C to B, we'll put that at the bottom, that's square root of 7. We've got the long leg going from C to the A, that is 2 square root of 5. And then that is similar to this medium-sized right triangle, where the right angle's at the D, and the short leg this time would go from D to C, and the long leg would go from D to A. Now what we know is D to A is an X, and A to C is 2 square root of 5. And then we've got the smallest of all the right triangles, okay, which is that B is, let's see, the D is at the right angle, D to B is that short leg down there, and D to C is this long leg, and all we've got is this hypotenuse of square root of 7. So, you know, if we think about these right triangles all being similar to each other, which ones would we use to create a proportion again, right? Well, definitely is not going to be the smallest one because we only have one length, so let's erase that. And unfortunately with these two right here, we don't have the same lengths, with the same sides. We've got short leg and long leg here, but we've got long leg and hypotenuse here, so that's not the same. But if you really look at this triangle, you see how I know the short leg and the long leg? Well, I can find that hypotenuse, let me call that a C, by using Pythagorean theorem. Remember we've done this before, right? Leg squared plus leg squared equals hypotenuse squared. So here's our leg, 2 squared to 5 squared. Here's our other leg of square root of 7 squared, and that's our hypotenuse squared, which is a C squared. So square root of 7 squared is easy, that's just plain old 7, because squaring and square rooting cancel each other out, okay? But it's not as simple here, because I got 2 square root of 5, the quantity squared. So that means, you know, I've got 2 square root of 5 times another 2 square root of 5, which is 4 square root of 25. Well, if square root of 25 is 5, then I've really got 4 times 5, which is 20. So now I've got 20 plus 7, which is 27, and that's equal to C squared. Get rid of squaring by square rooting, and the square root of 27 separates into square root of 9 times square root of 3, and the square root of 9 is exactly 3, so there we go, the hypotenuse is now 3 radical 3. Okay, so now that I've got the hypotenuse in there, well, let's erase this to make for some room. Okay, so now I do have the same two sides that I can use in a ratio. Let me circle them for you. I've got long leg hypotenuse, and I've got long leg hypotenuse, right? So I would go long leg of 2 square root of 5 over hypotenuse 3 square root of 3 equals long leg, which is x, over hypotenuse, which is 2 square root of 5. And now I gotta solve that by cross multiplying. So I've got 3 square root of 3 times the x equaling 2 square root of 5 times 2 square root of 5. Well, that's 2 square root of 5 squared, which I know is 20. I got to get rid of multiplication by 3 radical 3 by doing division of 3 radical 3. And then let's see what that looks like. Okay, that looks like x equaling 20 over 3 radical 3. Well, can't leave a radical in the denominator, so let me rationalize the denominator, right? So square root can always be rationalized as being multiplied by itself, right? So see square root of 3 over square root of 3. And now I'm going to just see what that gives me. So straight across the numerators is just 20 times square root of 3, so 20 square root of 3. Straight across the denominator, though, is 3 radical 3 times another square root of 3, which means 3 squared of 9. Well, square root of 9 is 3, and then 3 times 3 is 9. So there we go. There's our answer. Okay, so I hope it helped you to do some more examples today. I hope that solidified what we did on the first day of this, and that you feel good about doing the homework, and we'll talk about it on Monday. Bye all.